Hi students, in this video I am going to explain you the problems of exercise 6.5 of application of derivatives. This is of a maxima and minima. Maxima and minima. So there are different things in maxima and minima. Some functions we can find out directly maxima and minima. Some functions there is a process to find out maxima and minima. What is the process? I'll tell you first. For a function, the basic principle, this is the basic principle. For a function, for maximum or minimum to exist, the derivative of a function should be equal to 0. Okay? And you will get some values of x here. X equal to some a, b, something c, d, something like that. Okay? Now, there is a test here. You will be having a test, small test called second derivative test. Second derivative test. The test tells us, after getting the values of these two, you take the second derivative, find second derivative and substitute f double dash of a. If it is less than 0, then f has maximum value at x equal to a, and the maximum value is equal to f of a. You have to substitute that a in the main function of x. In the same way, for f double dash of x, if you substitute f double dash of b, if it is positive, then f has minimum value at x equal to b, and the minimum value will be f of b. Okay, this is the process of finding the maximum and minimum value of the function. The same process we go with the local maximum and local minimum also. And there are certain functions which we don't do this, and there are certain functions which we don't go with the double derivative. Those are to find out absolute maximum and absolute minimum. We don't go with double derivative. I'll tell you when the problems comes. So let us start the problems of the first 6.5 exercise. The first problem, in the first, f of x is equal to 2x minus 1 whole square plus 3. In this, no, I am not going to do the process of f dash of x equals 0 or f double dash of x, something like that. I go with the basic principles, general principle. See, this whole square is always positive, agree? Whole square value is always positive. So, this value is plus 3. So, positive value plus 3. That means, this value will be keep on increasing from 3. It will be keep on increasing from 3. So what happens here? The minimum value will be 3 and maximum value we don't know. Maximum value will be we don't know because it will be keep on increasing. So when you add some infinite term to 3, what happens? You will get infinity. So maximum value cannot be found in this case. In the second problem, suppose fx is equal to 9x square plus 12x plus 2, something like that it is there. So what I do, I'll make it into a perfect square so that whether we may get something like this. Okay. So 3x whole square, 2 into 3x, 6x into 2. It looks like a square plus 2ab, and write down this 2 here outside. Now this will become perfect square when we add and subtract b square. What is b here? 2. So add and subtract 2 square. Why we did this? And this term we wrote here. So till here it becomes 3x plus 2 whole square minus 2 for these two. It is minus 2. Now it is a whole square. Whole square is always positive. So the positive minus 2. Positive value minus 2, or you can write it as plus minus 2. That means the value will be increasing from minus 2. It will be increasing minus 2. After this value, this is a positive value. When you add 1, it becomes minus 1. When you add 2, it becomes 0. When you add 3, it becomes 1. That means it will be increasing from minus 2. So when it is increasing from a minimum value, when it reached value, the minimum value is equal to minus 2, and maximum value, because it is keep on increasing. If it keep on increasing, the maximum value cannot be found because we don't know where it ends. Understood? In the same way, third problem, fx is equal to minus of x minus 1 whole square plus 10. See what happened? What is happening here? It is positive, no doubt, whole square is positive, and 10 minus positive value. That means it is decreasing from 10. It is decreasing 10 minus positive value. 10 minus 1, 10 minus 2, or you can write like this also. 10 minus of x minus 1 whole square. When you see carefully, it is decreasing from 10. 10 minus 1, 10 minus 0, 10 minus 2, 10 minus 3, like that. So when it is decreasing, that means it has a maximum value. It has maximum value 10. Until where it decreases, we don't know. It goes to 10 minus infinity. So minimum value cannot be found here. Cannot be found. Understand? The next question, g of x equal to x cube plus 1. G of x is equal to x cube plus 1. So for this function, what happens? Can we have maximum value or can we have minimum value? No, we don't have we will have neither maximum nor minimum, because it will be keep on oscillating. It will be keep on oscillating, so it doesn't have a maximum or minimum value. So what we write here? G has neither maximum nor minimum, because we don't know where it starts, where it ends, because it is the power odd. Okay. Now in the second question, there are some different questions where we not required to apply the basic process. We do with the same, the general common concept, common sense. Okay. Mod x plus 2 minus 1. What is happening here? See, mod x is always a positive value. So you can also write 1 minus positive value. That means it is decreasing from 1. When it is decreasing from 1, so you have a maximum value as 1 and minimum value does not exist. Does not exist. Cannot be found or does not exist, anything. Second question, same. Oh, I'm sorry. I took wrong. This is wrong. You cannot find it this. Mod x plus 2 minus 1. This is a positive value minus 1. That means it will be keep on decreasing from minus 1. 0, 1, 2, 3. So it becomes we write like this, like how we did in the last problem, minus 1. So positive value plus something, positive value plus something. So it will have positive value plus minus 1. This is better. I did wrong. See, positive value plus something. So it starts from 0. It goes on increasing. When it goes on increasing, it increases from minus 1. So it has a minimum value. Minimum value is minus 1 and maximum value does not exist. Does not exist. When you have minus of a number, write it like this, it will be easy for you. Okay, next question is minus 1. This is right. Fx is equal to minus mod x plus 2, x plus 1 plus 3. So you can write this as 3 minus mod x plus 1. So it will be decreasing from 3 because it is positive value. When a positive value is subtracted from 3, it keeps on decreasing. So when it keeps on decreasing, the maximum value we know. Highest value is 3, but minimum value, we don't know where it goes. Minimum value does not exist. Okay. The same way, third question. Sin 2x plus 5. Fx is equal to, whenever you have some trigonometric functions, you can find out maximum and minimum values very easily, because we know the maximum and minimum values of some trigonometric functions very easily. Sin theta and cos theta, whether sin 100 or cos 100, whatever it may be, always they lie between minus 1 to 1, plus 1. You may ask, sir, if it is sin 100x, yes, even sin 100x lies between minus 1 to 1. Just add 5 on all sides. So 5 minus 1 less than or equal to 5 plus sin 2x less than or equal to 5 plus 1. So it becomes 4 less than or equal to 5 plus sine 2x less than or equal to 6. So maximum and minimum values are 4 and 6. Directly. Minimum is 4, maximum is 6. Right. In the same way, next one is also trigonometric function. Fourth one. Fx is equal to, it is modulus. Modulus of sine 4x plus 3. First of all, we go with sine 4x. Minus 1 less than or equal to sine 4x less than or equal to 1. When you add 3, it becomes 2 less than or equal to sine 4x plus 3 less than or equal to 4. Because I have added 3. Then it becomes, even when you take the modulus value, because this is positive, sine 4x plus 3 less than or equal to 4. So this is the minimum value and the maximum value is 4 for the given function. Next one is hx is x plus 1. X plus 1 and they have given minus 1 to plus 1. Minus 1 to plus 1. What happens here? So when you see the function carefully, it is a linear function. Hx equal to x plus 1 is a linear function. Linear means it's a line, degree 1. When a linear function is there, suppose it looks like this. It looks like this. So when you find something like, can you find out any minimum value and maximum value for this function? No. So it has, because a linear function will never have any ends. A straight line will never have any ends. Therefore, it has neither maximum nor minimum. These are the problems which we can do without using actual process. Now you will have a local maximum and local minimum in the next part, which we have to use the same process. First process f dash x equal to 0. Next finding the values of x. Next second derivative test, substituting those values in double derivative. Okay. See in the third question, local maximum and local minimum for the functions. Let us see. First one. F of x is equal to x square. So local maximum and local minimum. So let's go with the process. F dash of x, you find out 2x for maximum or minimum. F dash of x is equal to 0. 2x equal to 0. So x equal to 0. Now go with the double derivative. F double dash of x, it is 2. And 2 is positive. Without substituting only we are getting this thing. So when double derivative is positive, therefore f has a minimum value. Minimum value at x equal to 0. What is that minimum value? You have to substitute this value here in the main function f of 0. Minimum value f of 0 is equal to 0 square 0. Understand? This is the process. Second question, g of x is equal to x cube minus 3x. So we do the same thing. Let us go with the same process. First find out g dash of x. 3x square minus 3. What we know for maximum or minimum, this is the basic principle. G dash of x equal to 0. That means 3x square minus 3 is equal to 0. X square equal to 1. X is plus or minus 1. That means you got the two values. So let us go with the double derivative. G double dash of x 6x. But you have two values. So let us substitute g double dash of minus 1. 6 into minus 1 minus 6 less than 0. And g double dash of 1, 6 into 1, 6, it is positive. So when you have a negative double derivative, when you have a negative value in the double derivative, then g has maximum at x equal to minus 1. What is that maximum value? Substitute here. G of, we write here, maximum value is equal to g of minus 1. Main function you have to substitute. So minus 1 whole cube minus 3 into minus 1. Minus 1 plus 3, it is 2. In the same way, g has minimum because it is positive. Minimum at x equal to 1. And what is that minimum value? Minimum value is just substitute 1 in the place of x in the main function, g of 1. That is 1 cube minus 3 into 1. 1 minus 3 minus. This is the process, the basic process which we use in all the problems. Okay. Next one, third one. H of x is equal to sin x plus cos x and 0 less than x less than pi by 2. It means you are in first quadrant. 0 to pi by 2 means we have to search the values of x in the first quadrant only. So let us see, same process we go. H dash of x cos x minus sin x. What we know for maximum or minimum? H dash of x is 0. That means cos x minus sin x equal to 0. That means cos x is equal to sin x. 1 equal to tan x. When you take cos term, then x will be tan x will be 1 in the first quadrant. It will be pi by 4. Let's go with the double derivative. H double dash of x. It becomes minus sin x minus cos x. When I substitute h double dash of pi by 4, I get minus sin pi by 4 minus cos pi by 4 minus 1 by root 2 minus 1 by root 2 minus 2 by root 2. It is minus root 2, which is negative. When double derivative is negative, h has maximum at x equal to pi by 4. What is that maximum value? That maximum value will be h of pi by 4, main function. It becomes sin pi by 4 plus cos pi by 4. It becomes 1 by root 2 plus 1 by root 2, 2 by root 2. So root 2 is the answer for this. For the same type in the next function, see in this question, x values are given in one complete rotation. 0 to 2 pi means you have to go for all the 4 quadrants. Okay, let us see. First of all, f dash x derivative cos x plus sin x, because minus of minus sin x. What we know? We know that for maximum or minimum, f dash of x is equal to 0. That means cos x plus sin x is equal to 0. Sin x is minus cos x. Bring it down. Tan x is minus 1 negative. Where will be tan negative among all the 4 quadrants? Tan x will be negative in x equal to in the second quadrant. Second quadrant we write pi minus pi by 4, and also in the fourth quadrant. In the fourth quadrant we write 2 pi minus pi by 4. It will be 3 pi by 4 and also 7 pi by 4. Now we go with the f double dash of x. Double derivative. Double derivative becomes minus sin x plus cos x. So it becomes cos x, we write cos x minus sin x is the double derivative. Let us substitute. F double dash of 3 pi by 4. So it becomes cos 3 pi by 4 minus sin 3 pi by 4. Cos 3 pi by 4 means cos 135, it lies in the second quadrant. Minus 1 by root 2 minus, it will be 1 by root 2. It becomes minus 2 by root 2 minus root 2 negative. So double derivative value is negative. Therefore f has a maximum at x equal to 3 pi by 4. And what is that maximum value? Maximum value is equal to f of 3 pi by 4. Substitute here. It becomes sin 3 pi by 4 minus cos 3 pi by 4. 1 by root 2 minus 1 by root 2. It becomes 2 by root 2. The answer is root 2. Let's go with f double dash of 7 pi by 4. 7 pi by 4. It becomes cos 7 pi by 4 in double derivative minus sin 7 pi by 4. Cos 7 pi by 4, it's in fourth quadrant. Cos is positive. 1 by root 2 minus 1 by root 2, because sin in fourth quadrant is negative. It becomes plus 2 by root 2, and the answer is root 2 positive. Double derivative is positive. But double derivative is positive, f has a minimum value at x equal to 7 pi by 4. What is that minimum value? Minimum value is equal to, just substitute 7 pi by 4 in the main function. So it becomes sin 7 pi by 4 minus cos 7 pi by 4. Sin 7 by 4 is minus 1 by root 2. Cos 7 pi by 4 is 1 by root 2. It becomes minus 2 by root 2. So the answer becomes minus root 2. Okay? Right. Next, you see the fifth in this. F of x is given x cube minus 6x square plus 9x plus 15. Let us find out f dash x. 3x square minus 12x plus 9. Okay. See, we know that these are local maximum, local minimum, but I am not writing that because the same condition. You just write local maximum, local minimum, but you can write also maximum or minimum. Okay, what we know for maximum or minimum, f dash of x is equal to 0. 3x square minus 12x plus 9 equals 0. Just divide with 3 plus 3 equals 0. Okay, you can make it like x minus 1 into x minus 3. Factorize this. You have two values of x equal to 1 and x equal to 3. Now go with the double derivative. Double derivative. See, you cannot cancel here because it is not is equal to 0. Some people they do that. See, you have to cancel only here, but when you take double derivative, you should include these things also. 6x minus 12. So let us substitute f double dash of 1. 6 minus 12 minus 6 negative. Therefore, f has a maximum at x equal to 1. What is that maximum value? Is nothing but f of 1. That is 1 minus 6 plus 9 plus 15. 19. In the same way, f double dash of 3. F double dash of 3. Substitute in 3 here. 18 minus 12. That is 6 positive. When it is positive, we have minimum. F has a local minimum or minimum at x equal to 3. Now, what is that minimum value? Minimum value is f of 3. Main function. So, it become 27 minus 6 into 9, 54 plus 9 into 3, 27 plus 15. 27, 54 gets cancelled. The answer is 15. So, minimum value is 15, maximum value is 19 for this function. Next question, 6th one. G of x is equal to x by 2 plus 2 by x, and you are asked to take x positive values only. X positive value. Let us take the differentiation. Because this is the chapter application of derivative, so the basic thing that we have to do is differentiate the given function for maximum or minimum. Okay. G dash of x, it becomes 1 by 2 minus 2 by x square. Okay. What we know for maximum or minimum, g dash of x equal to 0. That means 1 by 2 minus 2 by x square equal to 0. 1 by 2 is equal to 2 by x square equal to 4, x equal to plus or minus 2. But you are asked to take only plus 2. So we take at x equal to plus 2. What is f double dash of x? F double dash of x. This is one derivative, no? 0 minus 2 into minus 2 by x cube. Derivative of 1 by x square is minus 2 by x cube. It is 4 by x cube positive. Because when you substitute 2 also it becomes positive. Okay. Positive at x equal to 2. Therefore, f has a minimum. Minimum at x equal to 2. And what? 2. What is that minimum value? Minimum value is g of 2. Sorry, it is g. Okay, g of 2 is 2 by 2 plus 2 by 2. That is 1 plus 1. 2 is the answer. Okay. Same process we do for this also. First find the derivative. G dash of x minus we treat it as 1 by x. Derivative of 1 by x is minus 1 by x square into derivative of chain rule. So it becomes minus 2x by x square plus 2 whole square. Now, what we know for maximum or minimum, g dash of x equal to 0. That means minus 2x by x square plus 2 whole square is equal to 0. Cross multiply minus 2x is 0. X equal to 0. We have only one value. So we don't know what value you are going to get double derivative. After double derivative only you can check. So let us find a double derivative also this for this. G double dash of x u by v. Let us put minus outside. X plus 2 whole square power 4 it becomes v square. So v u dash minus u. U is 2x v dash 2 into x square plus 2 into 2x. So when I substitute 0, it becomes 0. It becomes 0 plus 2 whole square 4. So the whole thing becomes negative because it is 0 and it is a positive value. Whole thing becomes negative. When the whole thing is negative, g has maximum value. maximum value. And what is that at x equal to 0? What is that maximum value? Maximum value is nothing but g of 0, main function. 0 square plus 2, it is 1 by 2. See, here also you are asked to take x positive value in 8th question. See, let us go with the same process. First of all, f dash of x, uv. X into derivative of this is 1 by 2 root 1 minus x into minus 1. Derivative of root of 1 minus x plus root of 1 minus x into 1. So it becomes LCM is 2 root 1 minus x. It becomes minus x plus 2 into 1 minus x. It becomes 2 minus 3x by 2 root 1 minus x. So for maximum or minimum, f dash of x is equal to 0. So 2 minus 3x by something, 2 root 1 minus x is 0. 2 minus 3x is 0. X is 2 by 3. We got only one value and you are asked to take positive value, so let us proceed. But you can decide the maximum or minimum only after doing the double derivative. Let us go with the double derivative. F double dash of x. This is u by v. So let us write 1 by 2 outside. So u by v we take. Okay. So it becomes 1 minus x v square v u dash minus 3 minus u 2 minus x v dash, derivative of this 1 by 2 root 1 minus x into minus 1. Now when I take LCM, it becomes 1 by 2 of 1 minus x to root 1 minus x. When you multiply this, it becomes minus 3 of 1 minus x plus 2 minus 3x. And this will 2 also will come here, sorry, it becomes 6. Now it becomes minus 6 plus 6x plus 2 minus 3x by 4 into 1 minus x into root 1 minus x. It becomes 3x minus 4 by 4 into 1 minus x root 1 minus x. When I substitute 2 by 3, f double dash of 2 by 3, what happens? 2 by 3 becomes 2 minus 4, negative, positive, positive. So the whole thing becomes negative when you substitute 2 by 3. When it is negative, f has a maximum value at x equal to 2 by 3. What is that maximum value? Maximum value is, substitute 2 by 3 in the main function. That means 2 by 3 root of 1 minus 2 by 3. 2 by 3 into 1 by root 3. That becomes 2 by 3 root 3. See, in the fourth question, you are asked to prove something. There are three functions here. Prove that these don't have maximum or minimum. Yes, we see. First of all, we know the process, derivative we take. For maximum or minimum, we should make f dash x equal to 0. For maximum or minimum, f dash x should be equal to 0. And e power x equals 0. It will never happen. You'll never find a value of x where e power x becomes 0. When it won't happen, it won't happen. Therefore, there exists neither maximum nor minimum. Neither maximum nor minimum. Because it will never become 0. In the same way. Second one, fx is equal to, it is log x. So the same process we go. F dash x is 1 by x. Do you find any value for maximum or minimum? F dash of x is 0. Do you find any value that it makes 0? Never. It will become 0 only when x is infinity. That is also no proof. Infinity has no value. So it will never become, or it will never happen. So therefore it is also wrong. There exists neither maximum nor minimum. In the same way, third one, you are given some function, a polynomial, f of x is equal to x cube plus x square plus x plus 1. Okay, let us see. F dash of x we do 3x square plus 2x plus 1. Okay, For maximum or minimum, what should happen? For maximum or minimum, f dash x should be equal to 0. That means 3x square plus 2x plus 1 should be equal to 0. Okay, let us see whether we get the factors. We don't have factors here. So let us go with the formula. When you go with the formula, x equal to minus b plus or minus root of b square minus 4ac by 2a minus 1 plus or minus 2 plus or minus root of 4 minus 12 by 2a. It is negative. That means imaginary roots you are getting. That means you don't have real roots, no real roots. When you don't have real roots, then this will not exist. When this will not exist, this will not exist. Therefore, f has neither maximum. That means this won't happen. This won't happen. Here f dash x you are writing, it means x is a real number. So f has neither maximum nor minimum value. This is the story. Okay. Now absolute maximum and absolute minimum. Whenever you find something like absolute or whenever you are given some closed interval problems, closed interval or absolute. Sometimes they don't give absolute. They give closed interval. Whenever you are given something like that, you no need to write or you no need to find out double derivative. Double derivative test is not required in this. Okay. Then how to do so? I'll teach you. See the first question of fifth. Fx is equal to x cube. We don't do double derivative when you have something like closed interval here. We do first f dash x as usual 3x square. For maximum or minimum f dash of x is equal to 0. 3x square is equal to 0. X square equals 0. You will have some one value or you may have 2-3 values also. Then what you do? We take this one. We substitute in the main function f of 0. 0 cube 0 and we take these two values also, f of minus 2 whole cube minus 8, f of 2 cube 8. So which is minimum here? So minimum value is minus 8 at x equal to minus 2. Maximum value is 8 at x equal to 2. See, this is the process to find absolute maximum or absolute minimum. See the next function, second one, f of x is equal to sin x plus cos x. So in the interval 0 to pi, in 0 to pi. Okay. As usual process we go with fx is cos x minus sin x. For maximum or minimum f dash of x is 0. Cos x minus sin x is 0. That means cos x is equal to sin x. So tan x is equal to 1. Tan x is positive. So between 0 to pi we get 45. So stop. Now what we do? We find f of 45. Don't go with the double derivative. Okay. Sin 45 plus cos 45. 1 by root 2 plus 1 by root 2. 2 by root 2 it becomes root 2. Now we go with these two values. F of 0, sin 0 plus cos 0, 0 plus 1, 1. F of pi means 180. So sin pi plus cos pi, it becomes 0 minus 1 minus 1. So what is the minimum value here? Minimum value is minus 1. Minimum value is minus 1 at x equal to pi and maximum value is root 2. Maximum value is root 2 at x equal to 45. This story. Okay, look here. Same concept. We go with f dash x first. 4 minus 1 by 2 of 2x. 2 gets cancelled. What we know for maximum or minimum, f dash of x is equal to 0. 4 minus x is equal to 0. X is 4. So let us substitute the values. First f of 4. 4 into 4 minus 1 by 2 into 16. It is 8. Next f of minus 2. Take these two values also. 4 into minus 2 minus 1 by 2 of 4 again. It becomes 2. So minus 8 minus 2 minus 10. Next f of 9 by 2. 4 into 9 by 2 minus 1 by 2 of 81 by 4. So it becomes So 18 minus 81 by 8. LCM is 8. 64. 146 minus 81. 65 by 8. Approximately this value will be 8 point something. So 8 point something. So minimum value will be minus 10. Absolute minimum. And absolute maximum will be 65 by 8. Let me check the answer once we get the fraction. It is minus 10 and 8. 146. 4 into 9 by 2, 1 by 20, 81 by 4. Oh, I did wrong here. It is 8, 8, 64. It is 144. It becomes 63 by 8. It becomes 7.9 something like that. So maximum value. Maximum value is absolute maximum. Absolute maximum is 8 and absolute minimum is minus 10. In the same way, the next question. Fx is equal to x minus 1 whole square plus 3 in the interval minus 3 to 1. Okay, let us see. First find out the derivative. F dash of x 2 into x minus 1 for maximum or minimum. F dash of x is equal to 0. 2 into x minus 1 equals 0. X equal to 1. So let us substitute f of 1. 0 plus 3, 3. F of minus 3. Minus 3 minus 1 whole square plus 3. 16 plus 3 it is 19. F of 1. 1 minus 1, 0 plus 3. 3. So minimum value is existing at two places. So one is there already. Fine, no problem. So minimum value is 3, absolute minimum, and absolute maximum is 19. Okay. So we don't go with the second derivative only in the case of absolute maximum or absolute minimum. Right. So the sixth question. Very simple one. Find the profit, maximum profit. This profit is given by an equation 41 minus 72x minus 18x square. They have asked us to find maximum profit, so we go with the same process. P dash of x derivative minus 72 minus 36x. What we know? For maximum or minimum, P dash of x should be equal to 0. So minus 72 minus 36x equals 0. 36x equal to minus 72. X is minus 2. So let us go with the double derivative. P double dash of x. It is minus 36 negative. Therefore, P has maximum profit at x equal to minus 2. What is that profit? Maximum profit will be P of minus 2. Substitute minus 2 in the main question. 41 minus 72 into minus 2 minus 18 into 4. 41 plus 144 minus 72. So 72, 113 is the maximum value. Okay. The same way. Next question also the same. Seventh one. Fx is given 3x power 4 minus 8x cube plus 12x square minus 48x plus 25. In the interval 0 to 3. 0 to 3 they have given. See, when they give something like in closed brackets, we go with the absolute maximum and minimum. So we go with the known. Second derivative is not required for this. So first of all, first derivative 12x cube minus 24x square plus 24x minus 48. Okay, keep it like that. For maximum or minimum, what we need? F dash of x should be equal to 0. Okay. Now, in all the things, I take 12 common here. Don't take 12 common here. When you are making it equal to 0, then only you take. X cube minus 2x square plus 2x minus 4 is equal to 0. Now I can factorize it easily. You can bring 12 to that side. 0 by 12 becomes 0. From the first two, if I take x square common, it becomes x minus 2. 2 if I take common, it becomes x minus 2, 0. So x minus 2 into x square plus 2 equals 0. Factors we got. And x equal to 2 is the only root for this because it will become negative. Square can never become negative. So I told you when you have close the bracket, we go with the absolute maximum or minimum. So let us go with f of 2 first. 3 into 16 minus 18 into 8 plus 12 into 4 minus 48 into 2 plus 25. So it becomes 48 minus 64 plus 48 minus 96 plus 25. 96 cancel. Minus 64 plus 25 becomes minus 39. Okay, let us go with f of 0. Clearly it is 25. Next f of 3. 3 into 81. 8 into 27. 12 into 9. 48 into 3 plus 25. 243 minus 756. 21. Okay. 108 minus 3 is 24. 144 plus 25. Let us add all the positive values. 243, 108, 25. $376. Next minus negative value 216, 360. It is 16. 376 minus 360, it is 16. So what is the maximum value we got? When x equal to 2, we got minus 39, 25 and 16. So minimum value is minus 39, maximum value is 16. Let me check it once. So minimum value is minus 39, right? Okay, maximum value is 25. We get 25 is bigger than 16. Yeah, it is right. Right, let's go to the next one. Okay, let's go with the 8th problem. At what point of the interval 0 to 2 pi, the function sin 2x attains its maximum value? Function fx is sin 2x in 0 to 2 pi. You have to check at 0 to 2 pi, and it is closed interval. Let us go with absolute maximum. First of all, f dash of x 2 cos 2x for maximum or minimum f dash of x is 0. So 2 cos 2x is 0. So cos 2x will be 0 when 2x is pi by 2 and also 3 pi by 2 in this interval. When I take x is equal, it becomes pi by 4 and also 3 pi by 4. I think I can also take pi by 2, 3 pi by 2 pi plus pi by 2. If 2x is 7 pi by 2, it becomes 7 pi by 4 because 7 pi by 4 means 7 into 45. 315, which is less than this. Okay, so you can take all these values. Let us substitute all these in this and let us check. First of all, f of pi by 4. So sin 2 into pi by 4, sin 90 it is 1. And f of 3 pi by 4. So sin 2 into 3 pi by 4, it becomes sin 3 pi by 2 minus 1. And f of 7 pi by 4, sin 2 into 7 pi by 4, 7 pi by 2 it is again 1 because it comes in the first quadrant, end of the first quadrant. Now we take these two, f of 0, sin 0, it is 0. And f of 2 pi, it is sin 4 pi, it becomes again 0. So what is the minimum value? Minimum value is minus 1 and maximum value is 1. Sorry, we have missed 5 pi by 2 here. Sorry, 5 pi by 2 and also 5 pi, 7 pi by 2. 5 pi by 4 and also 7 pi by 4. Let us find out the value of f of 5 pi by 4 also. Very sorry. So sin 2 into 5 pi by 4, it is 2, that is 1. So it will be on the top. 7 pi by 2 will be down, I think. Yeah. 7 into 7 pi by 4, 7 into 45. because 315, it will be down. It will be minus 1. I'm sorry, this is minus 1. So maximum value will be at 1 and minimum value will be minus 1. At they have given pi by 4 and pi by 4 it is maximum, and they have given 5 pi by 4 it is minimum, and you can take the other two values also. Okay, right. Now let's go to the next question. See the ninth question. Maximum value of the function, only maximum. In the before question also they have asked only maximum. Sin x plus cos x. Same process we go. F dash x cos x minus sin x. For maximum or minimum, what we know? For maximum or minimum, f dash of x equal to 0. That means cos x minus sin x equal to 0. Cos x is equal to sin x. That means tan x is equal to 1. That means x equal to 45. When x equal to 45, so what is the maximum value? F double dash of x also we take. Minus sin x minus cos x. When I substitute pi by 4, it becomes minus sin pi by 4 minus cos pi by 4. It becomes minus 1 by root 2 minus 1 by root 2 minus root 2, which is negative. So f has maximum at x equal to pi by 4. Let us substitute. What is the maximum value? F of pi by 4. We substitute this pi by 4 in the main function. Sin pi by 4 plus cos pi by 4. 1 by root 2 plus 1 by root 2. 2 by root 2. When you cancel this, it becomes root. Understand? Okay. This question, the same thing, you are asked to check maximum. It is given closed interval, we go with the absolute maximum and minimum. So f dash of x, same process, 6x square minus 24. So for maximum or minimum, f dash of x equal to 0. So I take 6x square minus 24 equal to 0. So x square is equal to plus or minus 4. Sorry, x square is equal to 4. So x equal to plus or minus 2. So I don't take minus 2 here because I have to take only plus 2 for this function between 1 to 3. And I can take minus 2 here in this case. So let us go with first f of 2. I am not doing second derivative because it is closed interval, and I go with the absolute maximum. F of 2. 2 into 8, 24 into 2 plus 107. 16 plus 107 is 123 minus 48. 123, 48. 75. Now f of 1. 2 minus 24 plus 107. 109 minus 24. 24. 79. Now f of 3. F of 3. 2 into 27, 54. Minus 24 into 3, 72. Plus 107. That means 161. 161 minus 72. 89. So the maximum value will be 89 and minimum is 75. Let me check it once. So they asked us only maximum. So it is 89 at x equal to 3. And let's go with this second one also. So when I take minus 2, f of minus 2 I have to go with, because minus 2 lies in between them. F of minus 2, it becomes 2 into minus 8, it becomes minus 16 plus 48 plus 107. That means 155 minus 16. 139. Now f of minus 3 also. Let us go with minus 3. 2 into minus 27 minus 54 plus 72 plus 107. 179 minus 54. 125. Now f of minus 1. 2 into minus 1 minus 2 plus 24 plus 107. 131 minus 2. 129. So maximum value is 139. You are asked only maximum value. Let me check it once. Yeah, it is at 139. Correct. You are right. Now let's go with the 11th one also. See the 11th question. It is given that at x equal to 1, this function fx is having, let's say ax plus 9 is having maximum value at x equal to 1 on the interval 0 to 2, closed interval. So at x equal to 1 it is having in the sense f dash of x should be equal to 0. That means f dash of 1 should be equal to 0. So let us take 4x cube minus 124x plus a equal to 0, and you can substitute 1 because at 1 you are told that it is 0. So minus 118 plus a equals 0. So a is equal to 118. I'm sorry, a is 120. 120 for 4. Very sorry. 120. See the 12th question. Fx is equal to x plus sine 2x. In sine 0 to 2 pi, we go with the absolute maximum minimum functions. Okay, let us see. First of all, f dash of x 1 plus 2 cos 2x. What we know? For maximum or minimum, f dash of x is 0. Okay, so 1 plus 2 cos 2x is 0. Cos 2x is minus 1 by 2. Negative. Cos 2x is negative. It will be in second and also in third. Suppose if you take it in second, 2x is minus 1 by 2, it will be 2 pi minus pi by 3, 2 pi by 3. If it is in third, it will be pi plus pi by 3. 2x is 4 pi by 3. And also you can take again one more rotation, because 2x is equal to again 2 pi. Next it will be negative in next rotation, 2 pi plus 2 pi by 3. 2 pi by 3, because I'll tell you why. 6 plus 2, 8 pi by 3. Because when you take x, it should lie in between them. When you take x, it should lie. It is x is pi by 3, x is 2 pi by 3, and x is 4 pi by 3. Then it lies in that. That is the main thing. Let us check for 2 pi plus 4 pi by 3. Let us see. 2 pi plus 4 pi by 3. If you take the second rotation also, 10 pi by 3. So 2x is 10 pi by 3. X will be 5 pi by 3. 5 into 6300. Yes, it lies. So it becomes 2x equal to 2 pi plus 4 pi by 3 also, because in two rotations you are taking. Why? Since they asked us to take in one rotation, why I am taking two rotations? Because we need the values of x, and these are the values of x, but you are getting the values of 2x here. Understand? So 2x is equal to 10 pi by 3. So x will be equal to 5 pi by 3. So let us substitute all the values including 0 and 2 pi. Let us see. First one, f of pi by 3. It will be pi by 3 plus sine 2 pi by 3. That means pi by 3 plus sine 2 pi by 3 is root 3 by 2. Next one, f of 2 pi by 3. 2 pi by 3 plus sine 4 pi by 3. Sine 4 pi by 3 will be, it will be in fourth quadrant. So third quadrant, 2 pi by 3 minus root 3 by 2. Next one, f of 4 pi by 3. f of 4 pi by 3. 4 pi by 3 plus sine 8 pi by 3. So 4 pi by 3, 8 pi by 3 means 8 into 60. 480. 480 means when you remove 360, it becomes 120. It lies in second quadrant. It is positive. So root 3 by 2. So f of 5 pi by 3 will be equal to 5 pi by 3 minus root 3 by 2. And whatever left, f of 0, 0 plus sine 0, 0. And f of 2 pi, I think this is the maximum value. 2 pi plus sine 2 pi, 2 pi plus 0, it is 2 pi. So minimum value is 0. maximum value is 2 pi, but these are all less than 2 pi only. When you check it carefully, you can understand. Okay. Now see, from the 13th problem onwards, actual maximum minimum problem starts. And these are for 6 marks questions. Very important, guys. Look carefully. Now, 13th question. Find two numbers whose sum is 24 and whose product is as large as possible. See, given what is given and what should be maximum or what should be minimum, you should identify first that in these questions. See, let the two numbers, this question is about the two numbers. Let the two numbers be x comma y. What is given? Given is x plus y is 24, and we can take it as the other variable also in the place of in the form of the first variable. And what did they say? Whose product is as large? Product is large. Product is large. Large means it should be maximum. So product. Let us take product as p of x is equal to, actually it is x into y. But why I take p of x? I want to convert everything in terms of x. You can take it as 24 minus x. This is product. So this should be maximum. This is given and this is maximum. So let us take 24x minus x square. So let us take the derivative p dash of x, 24 minus 2x. What we know for maximum or minimum? For maximum or minimum, p dash of x is equal to 0. 24 minus 2x is 0. So x is equal to 12. So x is equal to 12. After getting x, we have to check in the second derivative test whether this is giving maximum value or minimum value. That is very, very important, and it carries 1 mark for second derivative. P double dash of x will be minus 2. It is negative. Therefore, P has the maximum value at x is equal to 12. When x is equal to 12, what is y? 24 minus x. 24 minus 12, that is equal to 12. Okay? See the next question, 14th one. Same two positive numbers such that let the two positive numbers be x comma y such that what did they give? So x plus y is 60. Same process we do. Y is 60 minus x, and xy cube is minimum. Here it is minimum. So we take p of x is xy cube. You may ask, sir, why did you take p of x and it is xy cube? Let us convert. That was in terms of x. 60 minus x whole cube. Now the same process we do. P dash of x. UV rule. U 3 into 60 minus x whole square into minus 1 plus 60 minus x whole cube into 1. So from both you can take 60 minus x whole square common. It becomes minus 3x plus 60 minus x. So it becomes 60 minus x whole square into 60 minus 4x. So for maximum or minimum, what we need? For maximum or minimum, p dash of x should be equal to 0. That means when this is equal to 0, x is 60. When this is 0, x is equal to 60 minus 4x is equal to 0. So x will be equal to 15. We don't take x as 60 because when you take x as 60, then y becomes 0. But you are asked that non-zero positive. Positive in numbers means it should not be a 0. So we don't take x as 60, we take x as 15. Let us check whether we are getting positive, double derivative positive, because you are asked to take minimum value. So go for double derivative test. P double dash of x, UV rule again. So 60 minus x whole square into minus 4 plus 60 minus 4x into 2 into 60 minus x into minus 1. So when you no need to substitute also, even when you substitute x as 15, this whole thing becomes 0. And this becomes 60 minus 15 positive into negative. So it is negative. Okay. So what did they say? So maximum only. It should be maximum. Sorry, I thought minimum. Right. So it is negative. Therefore, P has maximum at x is equal to 15. So when x is 15, what is y? 60 minus 15, this is 45. Okay. Next question. Positive integers that the sum is 15. Question number 15. Let the two positive integers, same positive numbers be x comma y. That the sum x plus y is equal to 35 and product is maximal. So I take y as 35 minus x. P of x is given as x square y power 5. X square y power 5. Okay, let us do P of x is equal to x square into 35 minus x power 5. So let us find out P dash x derivative, UV rule. X square into 5 into 35 minus x power 4 into minus 1 plus 35 minus x power 5 into 2x. So it becomes, I take 35 minus x power 4 into x, common in both of them. So it becomes minus 5x here, and here 35 minus x into 2. That means it becomes 70 minus 2x here. Because 2 into 35 minus x. Now it becomes 35 minus x power 4 into x, 70 minus 7x. Now when I equate for maximum or minimum, P dash of x is equal to 0. When you take this equal to 0, x is 35, which we don't take because when x is 35, y becomes 0. Now, the other one is when you take x is 0, we don't take this also, it cannot be happen. When 70 minus 7x is 0, x value will be equal to 10. So let us see the double derivative. Whether the double derivative are getting negative or not, because they have asked us to find the maximum only. Here also it is maximum. So let us go with the double derivative. When I go with the double derivative, I take like this: 35 minus x power 4 into 70x minus 7x square. So you can take it as UV rule. Next step. So P double dash of x, 35 minus x power 4 into 70 minus 14x plus 70x minus 7x square into 4 into 35 minus x whole cube into minus 1. See, when you substitute x is equal to 10 here, it becomes, when you substitute x as 10, this becomes 0, the whole thing becomes 0. When I substitute, it becomes positive, and 70 minus 140 minus, so it is negative. Negative. Don't need to substitute, you can just check whether it is negative or positive. So P has, when it is negative, P has the maximum at x is equal to 10. When x equal to 10, what is y? Y equal to 35 minus 10, y is 25. Okay. Next one is also 16. Say two positive numbers such that let the two numbers be x comma y. The sum is 16. X plus y is 16. Y is 16 minus x as usual. The sum of whose cubes is minimum here. This problem is minimum. So I take P of x is equal to sum of cubes. So I take x cube plus what is y? 16 minus x whole cube. So P dash of x is derivative of this 3x square plus 3 into 16 minus x whole square into minus 1. What we know? For maximum or minimum, P dash of x is equal to 0. So it becomes 3x square minus 3 of 16 minus x whole square equal to 0. You can divide with 3. X square minus 16 minus x, 256 plus x square minus 32x equal to 0. X square gets cancelled. 32x equal to 256. X equal to 256 by 32. It is 8. When x is 8, so let us go with the double derivative. P double dash of x. P double dash of x is again derivative of this 6x. Again it becomes minus 6 into 16 minus x into minus 1. So it becomes 6x plus 6 into 16 minus x. So it becomes positive when you substitute x as 8. Therefore P has the minimum. What is P? This one. X cube plus y cube. minimum at x equal to 8. When x is 8, y is 16 minus 8. See guys, if you don't do double derivative, you lose 1 mark, okay, in the main answer, okay. See the 17th question, what is happening here? A square piece of tin of side 18 centimeters is made up into a box by cutting the pieces, and volume of the box is maximum. See, what is happening here? There is a square piece here, square piece of side 18. All the sides are 18, and some uniform part has cut on all the corners. When you remove those, you can make it a box. You can do with your some paper also. You can make a cake box like that. Okay, because when you cut these parts, when you fold them, it looks like a box. See, when it looks like a box, so what part is to be cut? So equal parts are cut along the corners. Okay, then what will be the length? This length will become 18 minus 2x. So length becomes 18 minus 2x, breadth also becomes 18 minus 2x, and height, whatever the height, see, when you fold it, the part which was cut, it stands and it makes a box. So whatever stands now, it is a height. So what is standing here? The part which was cut. How much part it is? It is x part. The length is x, so the height is x. And you are asked here to find the value of x, which part, how much part is cut, so that the volume is maximum. So I take volume of a box. Volume of box V of x I take LBH, volume of the cubic box, cuboidal box actually. So V of x is equal to 18 minus 2x into x. You can also take 2 common here, it becomes 4 into 9 minus x whole square into x. It will be easy for us to take the derivative. Okay, let us do the differentiation. V dash of x. 4 keep it outside. UV rule. 9 minus x whole square into 1 plus x into 2 into 9 minus x into minus 1. So you can take a common 9 minus x from the both. 4 into 9 minus x, if I take common, it becomes 9 minus x minus 2x. So it becomes 4 into 9 minus x into 9 minus 3x. This is the derivative. See, if you don't take common, if you multiply like that, you will get a very big thing, which will be a little difficult to simplify later. Now it is easy for us to simplify, because for maximum or minimum, V dash of x is equal to 0. So when you make this one equal to 0, it becomes 9 minus x 0, x equal to 9, which we don't take, because when x is 9, what happens? 18 minus, the length becomes 0, breadth also becomes 0. So no box. So I take 9 minus 3x is 0, so x will be 3. But we are not sure that it is giving maximum volume or not. So go with the double derivative. Double derivative, 4 into UV rule, UV. 9 minus x into minus 3 plus 9 minus 3x into minus 1. So if I substitute x as 3, it becomes 0. This becomes 0. When I substitute x as 3, 9 minus 6, 6 into minus is negative. Therefore, V has a maximum. That means volume is maximum at x equal to 3. So the answer is 3 centimeters has cut on all the corners. Okay. Now see the 18th question. Here it is not a square, it is a rectangle. Actually, the box is made with a rectangle here, but the corners are cut. The same corners are cut here. The length is 45 and breadth is taken as 24. So the part that was cut I took as x, 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 x. So the length and breadth will be changing here. Here also volume is maximum. Okay, let us see. Length becomes now 45 minus 2x. Breadth becomes now 24 minus 2x. Height will be same, which stands. It is nothing but x, because the one which was cut, that will be standing. Okay. Now volume of the box. Volume of box V of x is LBH. So V of x is equal to 45 minus 2x into 24 minus 2x into x. What I do is, UVW is becoming. So I make UV, take 2 common outside, it is a number. So just send inside x, it becomes 12x minus x square. When I take 2 outside, it becomes 12 minus x, send x inside. It will be easy for us to take the derivative. V dash f x becomes 2 into UV. 45 minus 2x into derivative of this is 12 minus 2x plus 12x minus x square into derivative of this is minus 2. Now what I want to do is I take the common thing whatever I can. I don't think I can take I can take only 2 common. Let us take 2 common from here and also 2 common from here. Put it outside. It becomes 4. So it becomes 45 minus 2x into 6 minus x minus 12x plus x square. Now let us multiply this better. 45 into 6, 270 minus 45x minus 12x plus 2x square minus 12x plus x square. So the whole thing become 3x square minus 69x plus 270. We got 24, 49, 69. Okay. Now I can take 2, 3 also common, become 12 of x square minus 23x plus 90. This story. Now let us go with maximum or minimum. This is at v dash of x only. For maximum or minimum, v dash of x is 0. So I can still do, let us factor this, I think 18 5s, x minus 18, x minus 5. So 12 into x minus 18 into x minus 5 is equal to 0. I don't take x equal to 18 because when I take x equal to 18, breadth becomes negative. There will be no breadth. So I take x is equal to 5. But I am not sure that it is giving maximum value. So go with v double dash of x. So 12 into derivative of this 2x minus 23. When x is 5, 10 minus 23 minus 13 negative. Therefore v has maximum at x equal to 5. So what is that maximum value? Did they ask? No. They just asked to find the value of x. Okay. See the next question, 19. Show that of all rectangles inscribed in a circle, the square has maximum area. That means the question looks little twisted, but it is very simple. All the rectangles that is inscribed in a circle. This is a rectangle actually. This is a rectangle. We have to prove that it will become a square when the area is maximum. What did they ask? They told something different way. They told us all the rectangles inscribed in a circle, the square has maximum area. What I am going to prove is, I take a rectangle inside a circle and I prove that if the area is maximum, it becomes a square. That's it. So how I do this? See, if I take a rectangle here like this and it is a diameter and I take radius r. Okay. Now, see, whenever something is inscribed in some other object, the outer object is fixed and it is constant. And the dimensions of the outer object is always constant. Remember this carefully. Whenever something is inscribed in some object, the outer object is fixed and it is constant. Whatever the changes happens, it happens only for the inner object. And here, so outside object means circle, so the radius, the dimensions of the outer object is always constant. So radius is constant here. Okay. Now when I take a Pythagoras theorem here, x square plus y square is a 2r whole square. It becomes x square plus y square is, or otherwise, y square is equal to 4r square minus x square. You can also take y is equal to root of 4r square minus x square. Now I consider area and I take maximum area. Area of rectangle is, area of a rectangle is x into y. So I take a of x because it is area. X into root of 4r square minus x square. What I do is, for the sake of convenience, if you take square of this, a of x as a square of x as f of x. then it will be easy for us to simplify. I suggest whenever you find some square roots in the question or in the main thing, you just take square of that, it will be easy for you to calculate. So I take a square of x, so f of x is this. Let us find out the derivative. F dash of x, uv, x square into minus 2x, because r square is constant here, plus 4r square minus x square into 2x. So I can take 2x common in both of them. It becomes minus x square plus 4r square minus x square. It becomes 2x into 4r square minus 2x square. So it becomes, take 2 common, 4x into 2r square minus x square. What we know, for maximum or minimum, f dash of x is equal to 0. So 4x into 2r square minus x square is equal to 0. So it becomes either x is equal to 0 or 2r square minus x square is 0. X square is equal to 2r square, x equal to root 2r. But we don't know that. This is giving maximum area. Area is maximum. So I go with the double derivative. So it becomes 4 is a constant. Let us go with uv. So x into minus 2x plus 2r square minus x square into 1. When I take x as root 2r, the whole thing becomes 0. Root 2r means 2r square. So it becomes 0. It becomes negative. Therefore, f has a maximum. F has maximum means area is maximum. Maximum at x equal to root 2r. So, sir, what did you prove? You told that you proved that it is going to be a square. Yes, I'll tell you. So, x is root 2r, then what will be y? 4r square minus x square. So 4r square minus 2r square. So it is also 2r square. Therefore y is also root 2r. When x is equal to y, the rectangle becomes a square. Length is equal to breadth, the rectangle becomes square. See the next question. The right circular cylinder of a given surface area. See 20th question. Here in these questions, when the problem is on cylinder, core, something like that, there are two things in this question, in every question. Given thing and what is maximum or what is minimum. Always you should start with the given thing. So what is given? The question is about cylinder and given surface. Given surface means total surface area is given. Given surface means total surface area. We start with like this. This is about cylinder. Given Tsa of cylinder only. Suppose if it is of lateral surface area, curved surface area, definitely they give us curved Csa. But they didn't give anything and they told us only surface area. It means that it is total surface area. Okay. Tsa of a cylinder will be of cylinder. I take it as S 2 pi RH plus 2 pi R square. Okay, this is the total surface area of a cylinder. And what did they say? Maximum volume when the height is equal to the diameter of the base. We have to prove that height will become the diameter of the base. Radius is R, h equal to 2R. H equal to 2R when it is maximum volume. Okay? Okay, let us see. After this, right. From this, I take something s minus 2 pi r square. We will extract something here. You may ask me that, sir, why did you extract only h? Why can't you extract r here? Yes, you can do that also, but it won't become easy here. When I try to extract r, like r is equal to something in terms of h, it won't come. It will be because we are having r in two parts, two terms, and we will not be able to extract separately r, but it is easy to extract h. This is h. Okay. Now, you are told that volume of a cylinder is maximum. So we start with volume of cylinder V of R, because we are going to convert the whole problem in terms of R. Actually, volume of a cylinder is pi R square h. So V of R, so I convert the h also in terms of R, this one. S minus 2 pi R square by 2 pi R. So pi gets cancelled, 1 R gets cancelled. So it becomes 1 by 2 of SR minus 2 pi R cube. Now, V dash of R, derivative of R, is equal to S is 1 by 2 of S into 1 minus 6 pi r square. What we know for maximum or minimum? For maximum or minimum, V dash of r is 0. So it becomes 1 by 2 of S minus 6 pi r square is 0. That means S minus 6 pi r square is 0. S is equal to 6 pi r square. But what is S? S is this 2 pi r h plus 2 pi r square is equal to 6 pi r square. 2 pi r h is 4 pi r square. 2 gets cancelled. Pi gets cancelled. R gets cancelled. One of the r. H equal to 2r. People think that the problem is over, but still there is some problem. The thing which is required is over. But still we have to prove that whether it is maximum or minimum, we don't know. To confirm that, go with the double derivative V double dash of r. So 1 by 2 of 0 minus 12 pi r. Why I took 0 as a derivative of s? Because always the given thing is constant. Always whatever given. In the question, if it is given, it means it is fixed and it is constant. Here surface area is given s. So I took it as a constant and the derivative of s is 0. Understand? So it becomes negative now here. Negative. Therefore, V has the maximum at h equal to 2r means diameter of the base. Okay. Right. Let's see the 21st question. They have given is of cylinder 1, but it is given volume. Volume of cylinder is given here. V is equal to 100 cubic centimeters. That means this is constant here. So what is the volume of the cylinder? Pi r square h is 100. H is 100 by pi r square. We take. I can extract r also here, but if I extract r, it becomes the root, square root on the right hand side, which is not good. It doesn't look good. So we can do like this. Now he told that surface area is a minimum. Okay. Minimum surface area means it should be total surface area. Total surface area is 2 pi r h plus 2 pi r square. Okay. Now S is equal to 2 pi r h is 100 by pi r square plus 2 pi r square. So you can cancel pi and you can cancel one of the r. It becomes 200 by r square plus 2 pi r square. This we take it as s of r. So we take the derivative of this also. 200 into 1 by r square derivative minus 2 by r cube 4 pi r. What we know for maximum or minimum? For maximum or minimum, s dash of r is equal to 0. It becomes minus 400 by r cube plus 4 pi r is equal to 0. Now it becomes, this is r, minus 2 by, minus 1 by r square, this is r only. Minus 200 by r square plus 4 pi r is equal to 0. Then 4 pi r is equal to 200 by r square. So it is 50. R cube is equal to 50 by pi. R equal to 50 by pi power 1 by 3. So when you get r value, let us check whether we are getting the minimum value or not. So for that we need the double derivative test. S double dash of r. Minus 200, if I take it outside, derivative of 1 by r square minus 2 by r cube plus 4 pi into 1. This is positive, this is also positive, so everything is positive. So double derivative is positive, therefore S has a minimum. So when you have r value, let us find out the value of h also. H is 100 by pi r square. Minimum at r is equal to 50 power 1 by 3 by pi power 1 by 3 pi, right? So now I substitute here pi r square is 50 power 2 by 3 by pi power 2 by 3 because square, r square. Now what I do? Now I convert it like 2 into 50 by pi power 1, 50 power 2 by 3 by pi power 2 by 3. Now when I look at 50s, it looks like a power m by a power n. A power m minus n. It becomes 2 into 50 power 1 by 3. The same way denominator pi power 1, pi power 2 by 3. A power m by a power n. Pi power also 1 minus 2 by 3. 1 by 3. This is the answer. And here also we got a h equal to, I think, 2r. See the next question, 22. A wire of length 28 centimeters. There is a wire. There is a wire of length. This is of 28 centimeters. It is cut into two pieces. One piece is made into a square, the other into a circle. So let us take into two pieces. One is x and the other one is 28 minus x. Let us make one as a circle, the other one as a square. He has made one as a circle, the other one as a square. So I take this as a circle and this as a square. That means this x part is made into a circle. This 28 minus x part is made into a square. It means this x becomes the perimeter, circumference of this circle. Because this x whole length is made into a circle. R equal to x by 2 pi. And here it is a side. If I take the side, each side as s. 4s is equal to 28 minus x. So s equal to 28 minus x by 4. So you get the values of r and s. Now what did they say? They asked us to show that the areas are minimum. The areas are the minimum. Then find the length of the two pieces. So areas are minimum. So let us take a of x as area of a circle plus area of a square. Area of a circle is pi r square. Area of a square is s square. This is pi into x square by 4 pi square plus s square is 28 minus x whole square by 16. Pi gets cancelled. 1 by 4 pi of x square plus 28 minus x whole square by 16. This is a of x. We take derivative. Same process we go with a dash of x. 1 by 4 pi of 2x plus 1 by 16 of 2 into 28 minus x into minus 1. Derivative of this. Okay. You can cancel this h. You can cancel this 2 pi. Now for maximum or minimum, I write it again. X by 2 pi minus of 28 minus x by 8. For maximum or minimum, a dash of x is equal to 0. So x by 2 pi becomes 28 minus x by 8. So cross multiply 4x equal to 28 pi minus pi x. If I bring x here, it becomes pi plus 4 of x is 28 pi. So x becomes 28 pi by. After getting the value of x, let us check whether you are getting the minimum or not. Minimum means the double derivative should be positive. Let us go with double derivative. A double dash of x 1 by 2 pi minus of minus 1 by 8. It is positive, minus of minus. Therefore, after getting the x value, the other length will be 28 minus x. So it becomes 28 minus 28 pi by pi plus 4. So it becomes 28 take common 1 minus pi by pi plus 4. So it becomes 28 into LCM is pi plus 4. Pi plus 4 minus pi. Pi gets cancelled. It becomes 112 by pi plus 4 is the other length. Okay. See, next question is the volume of the largest cone inscribed in a sphere of radius capital R is 8 by 27 of the volume of the sphere. See, volume of the largest cone 23. So there is a sphere here, a cone is inscribed in it. So I told you when an object is inscribed in another object, the outer object is constant. Here the cone is inscribed in a sphere, so the sphere is constant and the radius is R. This is R, capital R. Okay. Now if I take the dimensions of the cone, I take small r as the radius of the base of the cone and capital H as the height of the cone, and this part becomes, when it is total height, it becomes h minus r. This is h minus r. We write h is height of cone. R is base radius of a cone, and capital R is radius of a sphere. Sometimes they give radius of the sphere as smaller. Here they have given capital R, so we have to go with that. So now after this, just join this center with this, then it also becomes R. I just apply Pythagoras theorem for this right angle triangle because this will be the perpendicular thing. So when it becomes r square is equal to h minus, or otherwise I do like that. R square equal to R square minus h. Both capital R's will be on one side. This is the hypotenuse. Now it becomes, it looks like a minus b into a plus b. A square minus b square. So a plus b into a minus b. Be careful with the brackets. R gets cancelled. R square equal to h into 2r minus h. You can send it inside or otherwise leave it like that. Later we see. Now you are told that volume of the cone is maximum. So we start with the volume of largest cone. Largest means maximum. Volume of the cone V is equal to 1 by 3 pi r square h. That is the reason I didn't take square root here. So that you can substitute directly r square here like this. So it becomes V of h because I am replacing r here. So pi 1 by 3 pi. Instead of r square I write this h into 2r minus h. R square h again. Pi r square h. So it becomes pi by 3. Send h square inside 2r h square minus h cube. So v of h. So let us derivative this. Take the derivative of this pi by 3 of 4rh minus 3h square. We know for maximum or minimum v dash of h is equal to 0. So it becomes pi by 3 of 4rh minus 3h square is equal to 0. 4rh equal to 3h square. One of the h gets cancelled. H equal to 4r by 3. After getting this, let us check whether you are getting positive or not. Sorry, negative or not. Because it should be maximum. V double dash of h is pi by 3 of 4r into 1 minus 6h. Let us substitute h as 4r by 3. 4r minus, then it becomes 24r by 3. It is 4r, 12r minus 1, it is negative. So V has maximum at h equal to 4r by 3. But you are asked to prove something else. Volume of that largest cone. So volume of cone I take. Volume of cone 1 by 3 pi r square h. So I take 1 by 3 pi r square. So you have to find out r square also with this value of h. I do here. R square is equal to h into 2r minus h. So h is 4r by 3. 2r minus 4r by 3. 4r by 3 into 6r minus 4r, 2r by 3. 8r square by 9. This is small r square. Now I substitute these two values here. R square is 8 capital R square by 9. H is 4r by 3. Now you are told to take something like 8 by 27. So let us split 8 by 27 here. If I take 8 by 27 outside, 8 and 27, 8 by 27, it looks like 4 by 3 pi r cube. And it is nothing but 8 by 3 of volume of sphere. Right? Please pause the video and check it carefully, guys. See the 24th problem. The right circular cone of least curved surface area and given volume. Cone, it's about a cone. The problem number 24. It's about a cone. Least curved surface and given volume. Volume of a cone. So V is 1 by 3 pi r square h. So h will be 3V by pi r square. And we are told that it is the least curved surface area. Least curved surface area, and you are asked to prove that altitude is equal to root 2 times the radius of the base. Okay, we see. Okay, this is h. We have extracted h. Why you are not extracted r square? To avoid the square root. You know that. Now, least curved surface area. Clearly it is given curved surface area. We take as it is pi r l. So s equal to l means root of r square, plus h square. To avoid root, I told you to take s square, pi square, r square plus h square. To avoid the square root, you can do this. Okay. And you can take it as f of r. When you send it inside, it becomes pi square r power 4, pi square r square h square. Instead of h, I write this. It becomes f of r is equal to pi square r power 4 pi square r square instead of h square, it becomes 9v square by pi square r power 4. Pi square gets cancelled, one of the r square gets cancelled, r square. So it becomes pi square r power 4 plus 9v square by r square. Now take the derivative f dash of r, pi square 4r cube, 9v square, derivative of 1 by r square minus 2 by r cube. We know for maximum or minimum, f dash of r is equal to 0. So it becomes pi square 4 pi square r cube is equal to 18v square by r cube. Cross multiplying, 2 it is 9. 2 pi square r power 6, 9v square. So 2 pi square r power 6, v square is, actual v is this, 1 by 9 pi square r power 4 h square. 9 gets cancelled, pi square gets cancelled, r power 4 it becomes r square here. So 2r square equal to h square, h equal to root 2r. Proof is over, but still we have to prove that the double derivative is positive, because you are asked to prove minimum. So f double dash of r, if I take 4 pi square into 3r square again, minus 18v square, 1 by r cube derivative is minus 3 by r power 4, positive, everything is positive. Therefore f has minimum. Minimum means least curved surface area, least Cbse with h equal to root 2r. Okay. See, in this question, semi-vertical angle of a cone of maximum volume. Volume is measurement of given slant height. Slant height is given. Slant height. Slant height is given. And you are asked to prove that theta is the tan inverse root 2. Okay. So that means L is constant here. L is constant for a cone. Okay. L, this is R, this is H. So let us replace H or R in terms of L. So, and you are told that volume is maximum. Okay. We start with volume of cone. So volume of cone V is 1 by 3 pi r square h. We know L square equal to r square plus h square. So instead of r square I write L square minus h square, so that the whole problem will be converted into h, and you can also write f of h. 1 by 3 pi h cube, and L is constant. Why? Because it is given. So okay, slant height is given. Now take f dash of h, pi by 3, L square into 1 minus 3h square. So for maximum or minimum, f dash of h is equal to 0. So it means L square minus 3h square is equal to 0. L square equal to 3h square. So h square is equal to L square by 3. So h equal to L by root 3. In the same way, let us find out, we need angle. Angle will be here, theta. Okay. Now, tan theta. Before going to angle, let us see whether it is maximum or minimum. So go with the double derivative also. F double dash of h. It becomes pi by 3 of 0 minus 6h. Clearly it is negative. Therefore f has maximum. F has maximum means volume is maximum. H equal to L by root 3. Okay. Now, see, what is the formula of, he needs theta here. See, H and L are available here. So if I take cos theta, it becomes H by L. H by L. If I take cos theta, it becomes H by L. But you are asked to prove that in terms of tan. For tan, I need R by H. No? I need R by H. So I take R also. So let us find out R square. R square is L square minus H square. So L square minus L square by 3. 2L square by 3. It becomes, okay, leave it like that. So R will be equal to root 2 L by root 3. Root 2 L by root 3. Now tan theta, because you are asked to prove that in terms of tan, R by H. R by H means root 2 L by root 3 by L by root 3. L by root 3 gets cancelled. Tan theta is equal to root 2. Theta is tan inverse root 2. Okay. See the 26th question here. Given surface area of a cone means TSA of a cone is given. TSA of a cone. S equal to 2 pi r square plus pi rl. This is the TSA of a cone. And volume is maximum sine inverse. In terms of sine they asked us. Okay. Let us see. Here L is there. So if I want to convert everything in terms of R and H, it becomes root. So to avoid root, I told you square on both sides. When you square on both sides, it becomes S minus pi r square whole square, pi square r square into r square plus h square. This looks like a minus b whole square. A square plus b square minus 2ab. It becomes pi square r power 4, pi square r square h square. Pi square r power 4 gets cancelled. Now it becomes h square becomes s square minus 2s pi r square by. So what is our aim? Why we are doing all these things? To just extract one of the variable from the formula. And volume is maximum here. So volume of cone is taken as V is 1 by 3 pi r square h. But we have h square here to substitute. I'm sorry, it is r square. Okay. So what I do is, I take square of this 1 by 9 pi square r power 4 h square, so that the whole thing becomes in terms of r here. F of r 1 by 9 pi square r power 4 h square. I write this one, s square minus 2s pi r square by pi square r power pi square r square. This is also pi square. Pi square gets cancelled, 1 of the r square gets cancelled. F of r become 1 by 9 s square r square minus 2s pi r power 4. Now f dash of r 1 by 9 s square constant, because it is given. Given is always constant, guys. 2r 2s pi 4r cube. Okay, for maximum or minimum. Maximum or minimum. F dash of r is 0. So it becomes 2s square r is equal to 2s, okay, 8s pi r cube. 1 of this r square to 4 times. So s becomes 4 pi r square. But actual s is pi r square plus pi rl is 4 pi r square. So pi rl become 3 pi r square when you send it that side. Pi gets cancelled. 1 of r you can take over. L equal to 3r. See, when you take figure, it is L and it is r and it is theta, it is h. When you want sine theta, it is opposite side by hypotenuse. Here you are asked to find sine theta only. But I told you many times, don't forget to go with double derivative. Double derivative is 1 by 9 of, it becomes 2s square into 1 minus 8s pi. This is 3r square. 3r square. Now, we don't know whether it is giving negative or positive. When L is equal to 3r, find out yes, what is the value of s? If I substitute 3r, it becomes 3 pi r square, 4 pi r square. S value is 4 pi r square. Now the whole thing becomes 16 pi square r power 4 minus 24 okay, we do here s equal to pi r square plus 3 pi r square 4 pi r square. After getting s, substitute here, or we do one thing, take s outside, one of this, it will be easy. 2s if I take s minus 12 pi r square, but s is 4 pi r square, so it is negative. It is negative. So what did they say? Okay, maximum value. When it is negative, it is maximum. When L equal to 3r, let us do here. I am doing here, guys. Look here. Sine theta. What is sine theta? Opposite side by hypotenuse. r by L. But in the place of L I write 3r. Then it become 1 by 3. Theta is sine inverse. They may ask in terms of any other trigonometric ratio. They may ask cos inverse, they may ask in tan inverse, anything. But anything you can do. But while doing double derivative, be careful when you are substituting. Okay? See how I did here. I'll tell you again. After getting L, I substituted here. I got the value of S. And I just substituted the value of S here. See S 4 pi r square. If I substitute here, it becomes negative. Right. See the 27th problem. The point on the curve x square is equal to 2y. X square is equal to 2y, which is nearest to the point. Some p is given here 0, 5. First of all, when there is an objective type question, no, you just need to give the answers. So we go from the options. So let us check from the points given there. 2 root 2, 4. Let us substitute this in the place of x and y. So x, it becomes 8 equal to 8. So it satisfies. So this is q we take. And find out the distance pq. So square root of x2 minus x1 whole square plus y2 minus y1 whole square, it is 3. In the same way, second option. It is 2 root 2, 0 q. 2 root 2, 0 will not satisfy this. 8 equal to 0, so it won't satisfy, no need to check. C. Third option, if q is 0, 0. 0, 0 satisfies this equation. Okay, let us check pq here now. So square root of pq. 0 plus 5 square, it becomes 25, it is 5. In the same way, take d. When q is 2, 2. 2, 2 also satisfies this. 4 equal to 4. So pq will be equal to square root of 4 plus 9 root 13. So you are asked to check the minimum distance. What is the minimum distance among all these three? So this is the minimum distance. So the answer is A. Okay. Next. So the next question. F of x is equal to 1 minus x plus x square by 1 plus x plus x square. We are asked to find out the maximum value of this function. How? So same process, we take f dash x. For maximum or minimum, f dash x is 0. Let us see. U by v square, v u dash minus 1 plus 2x minus u into v dash 1 plus 2x. Let us multiply everything. Minus 1 minus x square plus 2x plus 2x square plus 2x cube. Put a bracket here. 1 minus x plus x square plus 2x minus 2x square plus 2x cube by 1 plus x square whole square. See, for maximum or minimum, or otherwise you can cancel. What can be cancelled here? 2x and minus 2x gets cancelled. 2x cube and minus 2x cube get cancelled. Minus x and minus x gets cancelled. So what are left here? Minus 1, minus 2. 2x square minus x square, 1x square and 1x square. Plus 2x square by 1 plus x square whole square. This is f dash of x. For maximum or minimum, f dash x should be equal to 0. Therefore, minus 2 plus 2x square is equal to 0. Denominator cross multiply, it becomes 0. X square equal to 1, x equal to plus or minus 1. So you have two values, x equal to minus 1 and x equal to plus 1. No need to go with the double derivative. Let us substitute here. One will be the minimum, one will be the maximum. So f of, because it is a multiple choice question, f of minus 1 will be 1 plus 1 plus 1 by 1 minus 1 plus 1. It will be 3. And f of 1 will be 1 minus 1 plus 1 by 1 plus 1 plus 1. It is 1 by 3. So minimum value is 1 by 3. They have asked us to find out the minimum value only. It is 1 by 3. If they ask maximum, it is 3. Okay. See the 29th question. Fx is given like this and you are asked to find the maximum value. Okay. See, when you see carefully, we take f dash x equals 0, no doubt in that. But when you see it carefully, it looks like an absolute because closed interval. It means that closed interval 0 to 1. When it is given like that, we go with the absolute maximum and minimum. So for that, no need to take a double derivative. So what we do? So we take this function as x square minus x plus 1 power 1 by 3. So let us do the derivative. F dash of x, it looks like some x power n. 1 by 3 into x power n, 1 by 3 minus 1 minus 2 by 3 into derivative of this is 2x minus 1. So for maximum or minimum f dash of x is equal to 0. That means 2x minus 1, this I write in the denominator because the power is negative. So 3 into x square minus x plus 1 power 2 by 3 is equal to 0. It becomes 2x minus 1, 0, x is 1 by 2. 1 is x is 1 by 2. So we find all the three values. 1 is x is 1 by 2. It becomes 1 by 4 minus 1 plus 1. Sorry, 1 by 2 minus 1 by 2 plus 1 whole power 1 by 3. That is 1 by 2 plus 1 by 4. 3 by 4 power 1 by 3. The other one is f of 0. F of 0 will be 0 plus 1 power 1 by 3. It is 1. And f of 1 also. It is also 0 plus 1 power 1 by 3. It is 1. So they have asked us to find out the maximum value. So maximum value is 1. Yes, it is right. Okay.